let's have a look at the second of the factorisation techniques that we've looked at in the past. This one's the difference of two squares. Okay, the first technique is the common factor technique, and whenever you're given anything to factorise, that's what you should check first. Can you factorise it by the common factor technique? If not, the next thing you ask is it the difference of two squares? Okay, so let's give you some examples of factorising using the difference of two squares. Number one, got to factorise x squared take away 25. Okay, well in this particular case you've got to factorise that, so you've got to rewrite it in a bracket notation, and I think you can quite clearly see it does not have any common factor. There isn't a number and there isn't an x that is in both terms. The only thing that you could put into both terms is actually the number 1, but if you actually took out a common factor of 1, you don't really need to write this down. What you'd be left with is 1 bracket x squared minus 25. So you still retain the x squared minus 25. So in fact, that is not a factorisation in the true sense. So you wouldn't be bothered taking out a common factor of 1. So we'll forget about that. Okay, so you're looking at this, and you should recognise it's the difference of two squared terms. First of all, you've got two terms. Take away in the middle means it's a difference, and that's a squared term obviously because it's x squared, and you've got to realise that 25 can be written as 5 squared. So this can be written as x squared minus 5 squared. Quite clearly now that is the difference of two squared terms. If it's the difference of two squared terms, then there is an automatic pair of double brackets that you just write down for the two factors. Okay, if it's x squared, you just have x and x. If it's 5 squared, you put 5 and 5. And if it's x squared minus 5 squared, one's a plus and one's a minus. And that's it. You could put the signs the other way around, the minus first and the plus second. But that's it. If you were to expand that out, you would find that you'd get x squared minus 25. Okay? There are actually 4 terms that come out, first times second, second times first, second times second, but what you'll find is that 2 of them with x's in cancel each other out and just leave you with those 2. Okay, let's just speed up then. Bit more practice. X squared minus 81. Okay, 2 squared terms. This is x squared minus 9 squared. Okay, x squared minus 9 squared, factorise it, double bracket, is going to be x minus 9 and x plus 9. Or the other way around. Notice first time I put the plus first, the minus second. Here I put the minus first and the plus second. It doesn't matter. Okay, that's it. That's as simple as that. Third one. How about x squared minus 400? Okay, a bit bigger number to deal with, but simple enough. Okay, squared term. That is a squared term because you need to realise it's x squared minus, and then 20 times 20 is 400. So it's x squared minus 20 squared, which will be x squared, sorry, let me write it in double brackets. It'll be x and x because of the x squared, it'll be plus 20 and it'll be minus 20. And that's how you factorise that one. So all very straightforward. I'm just going to go through 4 or 5 more examples on this video so you get the idea. So that's 3 very simple ones. Okay, number 4. Sometimes you might have something like this, x squared minus y squared, and say factorise that. Well, you can quite clearly see there that this is the difference of 2 squared terms, a squared term, square term. So it can factorise into 2 brackets. X squared means x and x, y squared, y and y, one's a plus and one's a minus. And there you go. If you were to expand that out, you'd get the line above. Okay, number 5. X squared minus a quarter. Okay, well this one is not so obvious, but I have seen this in various past papers over the years. If you wanted to factorise this, this would be x squared take away, and then you've got to realise that a quarter is the same as a half squared, because a half times a half is a quarter. You might say to yourself, well, I would never have spotted that. Well, the key to it is to realise you've got two terms and to take away. Square term, take away. I'd always be looking, if I've revised my work and I'm familiar with difference of two squares, I'd always be looking to see if that second term there can be written as a square term. And a quarter can. It can be written as a half in a bracket squared. So the two brackets for this one will be x and it'll be a half times a half. That would give you the quarter. One's a plus and one's a minus. There you go, there's the two factorisations. Okay, question 6. Quite often this sort of thing happens, and this is where people start really getting a bit confused. You might have something like this: 4 squared minus 9, like so. To me that stands out like a sore thumb that that's going to be difference of two squares. There isn't a common factor. You can try as much as you like, there's no common factor there. Equals, it's going to be the same as, now it's obviously take away 3 squared there, because 9 is the same as 3 squared. It's this thing here that causes the problem. You've got to say to yourself, what, when you square it, gives 4x squared? Well, the answer will be 2x. When you square it, gives 4x squared. It's 2x times 2x gives 4x squared. So you've got 2x in a bracket, all squared, so there's the first squared term, take away, and then you've got 3 squared, which is the second squared term. Okay, so what we get then is a double bracket multiplied together. If it's 2x in this bracket, you'll have 2x and 2x. If it's minus 3 squared, you'll have plus 3 and minus 3, or the other way around, minus 3 plus 3. Okay, this one here is very, very common, and it catches people out all the time with this first term here, like that, it's 2x in the bracket squared, so be careful. Okay, make some more space, a few more very quickly. I think we're up to number 7 then. So if you had something like 16 minus 25y squared, and you're asked to factorise that. Okay, is there a common factor? No, there isn't. So, okay, is it the difference of two square terms? Yes, it is, because that is the same as 4 squared, take away, and then 25y squared is the same as 5y times 5y. So it's 5y squared. So there's one square term, there's another square term, and we've got the difference of them. Okay, so therefore the two brackets will be 4 squared means 4 and 4. One's a plus, one's a minus, and then if that's 5y in a bracket squared, it'll be 5y and 5y. As simple as that. Okay, and then number 8. Okay, how about this one then? How about 64x squared minus 49y squared? You've got to factorise that. Okay, is there a common factor? No, there isn't. There's no common factor there. So can it be written as the difference of two square terms? Yes, it can. Because this is the same as 8x in a bracket squared minus 7y in a bracket squared. That is the same as that, and that is the same as that. We've got the difference of two square terms. Okay, this is the same as, it's going to be a double bracket then. We've got 8x and 8x, we've got 7y, we've got 7y, one's a plus and one's a minus. And there you go. Simple as that. That's the factorisation finished. Number 9, I would sort of suggest you might want to highlight this in your notes if you're making notes. This always catches people out. Let's have a look at this one. 2x squared minus 18. You've got to factorise that. Okay, well, you say to yourself, right, this is the process you'd go through. Has it got a common factor? And before you just jump in and say no, because we're doing completing the square, be careful, because this one does have a common factor. Number 2 actually fits into both 2 and 18. So if it's got a common factor, you should take that common factor out first. So you take out the 2, and for the moment, everything else goes in the bracket. 2 times x squared gives you 2x squared. 2 times minus 9 gives you minus 18, so we get to there. Now you've got to realise that we can carry on, because the x squared minus 9 is actually now a difference of two squares factorisation. So we did common factor first, and now we're going to do a second stage of factorisation using difference of two squares. X squared minus 9 is the same as x squared minus 3 squared. So I can factorise this into x plus 3 and x minus 3, like so. So you actually get three things multiplied together. Two of them are brackets and one of them is the number 2. And the 2 should always go at the front. Okay? Technically it doesn't matter which order you multiply things in, so I could technically put the 2 at the end if I wanted. But it looks neater, two lots of the double bracket. Okay, that's a very common question as well. I'd definitely make sure that you're prepped for that for any exam that you sit. Okay, let's do a couple more, and basically that will be it then. So if I did number 10, so if you had something like 4y squared minus, let's say 36, something like that, you're going to factorise that. Right, okay, well, ask yourself, has it got a common factor? Yes, it has. 4 goes into both. So you take out the 4 as a common factor, and you're left with y squared minus 9 inside a bracket. That times that is that, that times that is that. But you haven't finished. If you stop there, you've simply partially factorised it. It's like, once again, you have a fraction 4/8 and you cancel it to 2/4. You've partially cancelled it. You haven't cancelled it to a half, which is the simplest version. So if you stop there, you've only partially factorised it, and you'd only get limited credit for that, probably 1 mark out of 3. Okay, so you leave the 4 alone, and you've got to realise that y squared minus 9 is y squared minus 3 squared. So that means it's difference of two squared terms, y minus 3y plus 3, or plus 3 minus 3, it doesn't matter. There you go, there's the factorisation complete. Okay, number 11. How about 200 minus 2x squared, something like that. Okay, has it got a common factor? Yes, it has. What is the common factor? 2. The rest goes inside a bracket. 2 times 100, 2 times minus x squared. Can this thing here now factorise? Yes, it can, because 100 is the same as 10 squared, and that is x squared, and we've got the difference, so we can apply the difference of two squared terms to that bracket. So you get two lots of, if you want to do this, I've stopped doing it in the previous couple of examples, just to help you. So I've written the 100 as 10 squared. The final answer will be difference of two squares, two brackets. If that's 10 squared, it's going to be 10 and 10, plus and a minus, that's x squared, x and an x. There you go, you get three things multiplied together. That times 2 is the same as that line up there. And finally, number 12, excuse me, you might have something like 18x squared minus 72. Okay, something of that nature. Looking at this, you can see that there is a common factor. Common factor is 18 x squared, and I think 4 18s make 72, and this is the same as 18, and then this once again now difference of two squared terms, x squared minus 2 squared, so you can have x minus 2 and x plus 2, and there you go, that's the end of that factorisation. So the harder ones involve a two-step process of common factor first, followed by difference of two squares, the double bracket. And these type here, the two-step process, are very common questions. Okay, that's the end of this video. In the next video, we're going to look at factorisation using the simple table method.